Well, you see, I keep wondering, if you and I were to drift together toward the farthest darkness we can imagine, what would we find waiting there? Is there truly an edge to the universe? Some great cosmic shoreline where everything simply stops? Or is that edge only a trick of our eyes, a limit painted by the light that has not yet reached us? And, perhaps that's the thing. Every time we lift our gaze to the night sky, we're really asking a much older question. Not just what is out there, but how far our curiosity is allowed to go. I suppose the idea of a boundary, a cosmic border, feels familiar because in our everyday lives, everything has an ending. A road, a coastline, a breath. Yet when we talk about the universe, the largest stage we know, those simple rules begin to crumble. You see, some imagine the edge as a vast wall of darkness, a final frontier waiting to be touched. Others picture it as a glowing curtain of ancient light, the farthest echo of creation whispering back to us. And as we move into the quiet hours of the night together, I'd like to invite you to linger with that thought. What if the edge is not a place at all, but a signpost of our own perception? And well, as we follow this thread through the darkness, we'll unravel why the edge people often talk about is rarely the edge science speaks of. We'll trace the limits of what we can see, what we can measure, and what we can only imagine. Because somewhere in that tension between knowledge and wonder, that's where the universe becomes truly beautiful. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. Well, you see, when we step into this first chapter, we are really stepping into a quiet conversation humanity has been having with the night sky for as long as we have known how to wonder. And, I suppose the simplest place to begin is with an image almost all of us carry, even if we have never said it aloud. If the universe began somewhere, then surely it must end somewhere. Surely there must be a rim, a boundary, a final shimmering line beyond which there is only nothingness. It is such a natural thought, so deeply shaped by the world we touch every day. A table ends, a path ends, a shoreline ends. So why would the universe be any different? But the thing is, when people imagine this edge, they often picture it as a great cosmic wall, a kind of celestial cliff where galaxies cluster densely on one side, and on the other side there is an infinite abyss of non-existence, as if someone took a paintbrush and stopped mid-stroke. And well, that picture is charming in its simplicity, but the universe is rarely simple. If you could fly toward that imagined wall in a starship and approach it with all the bravery of mythic explorers, you would find no sign of it at all. No barrier, no membrane, no glowing seam in the dark. Just more space, more galaxies, more time stretching out before you, as quietly and endlessly as ever. Modern science, perhaps a little less dramatic but infinitely more mysterious, tells us that there is no physical wall at the end of the universe. This is not because we have not found it yet. It is because, as far as every measurement and model suggests, such a thing does not exist. The universe is not built like a room with edges. It behaves more like a vast landscape, one that might curve back on itself or stretch outward without limit. When we talk about whether there is an edge, we are often confusing two very different ideas: the edge of space itself and the edge of what we can observe. And, that second idea is the one that quietly sneaks into our minds without warning. We look up, we see a limited sky, we imagine a limited universe. But the limit is not in the universe. The limit is in our vision. There is a profound difference between a real physical border and a perceptual one. Light needs time to travel. And, well, that means there is a farthest distance from which light has had time to reach us since the universe first lit up. Beyond that distance, the light is still on its way, still crossing the ancient sea of space-time, and we simply have not received it yet. So the edge people think they are talking about is often only the edge of the observable universe, a horizon of knowability, not a cosmic wall. You see, the question, does the universe have an edge, becomes tangled because we are using the same word for two very different boundaries. A physical boundary would be something you could, in theory, touch, though you never would, because physics suggests no such boundary exists. But a perceptual boundary is something much more human. It is the frontier of our instruments and our understanding, marked not by stone or steel, but by the speed of light itself. The universe could continue forever beyond what we can see, humming with galaxies we will never know. And yet our perception tells us there is a curtain, not because the universe ends, but because our ability to observe does. And perhaps you might wonder, if the universe has no edge, then what shape is it? Well, scientists explore many possibilities. Some models describe the universe as open, expanding forever in all directions like a great unfurling plain. Others describe it as closed, curved upon itself like the surface of a sphere, finite yet without edges. And some depict it as astonishingly flat, stretching with perfect balance between openness and closure. Each of these shapes changes the way we think about edges. In a closed universe, for example, you could travel straight forever and eventually return to where you began without ever encountering a boundary. Much as a traveler on Earth can walk around the globe without falling off a cliff. In an open universe, the journey would simply never end. In a flat universe, things become subtler still, for flatness at this cosmic scale means not what we imagine in everyday life, but a delicate equilibrium in the geometry of space-time. Whatever the case, none of these models require a wall at the end. They do not need a final line or a cosmic lid. And, that is the thing that can feel so strange from a human perspective. Our minds evolved to navigate forests, rivers, mountains, cities, places with edges and endings. To encounter a universe without a border feels almost like trying to grasp the wind. It slips through our fingers. Perhaps the deepest misunderstanding, though, lies in the way we imagine the universe expanding. Many people picture galaxies rushing outward into some larger space, like ink spreading in water. And well, if that were true, we would naturally ask what lies beyond the ink, what lies beyond the water, what lies outside the cosmic stretch. But in truth, the expansion of the universe is not an expansion into anything. Space itself is changing. The distances between galaxies grow because the very fabric of space-time stretches. There is no external container, no outside. Asking what lies beyond the universe becomes as slippery as asking what lies north of the North Pole. And as we sit with this thought in the late hours when the mind is soft and receptive, the distinction becomes almost poetic. The edge of the universe we speak of so often is not a property of reality. It is a property of our perception. The universe does not end at its edges. Our understanding does. That is why scientists often say that the so-called edge is a cognitive illusion, a boundary drawn not by nature, but by the limits of our observation and our intuition. The actual universe could be infinite, or finite, but unbounded, or something stranger still, perhaps shaped by dimensions we do not yet perceive. Whatever it is, its true extent does not align with our simple mental picture of a border. Instead, it stretches far beyond anything our senses can grasp, and our instruments, even in the early years of 2025, can only trace a fragile bubble of visibility around us. And this brings us gently to an important scientific truth. When we speak of the edge, we are almost always speaking about the boundary of the observable universe, a region determined not by cosmic architecture, but by light itself. Light that has traveled across billions of years to meet us. Light that began its journey long before Earth formed, long before our sun ignited, long before the atoms in your body even existed. And yet, even that breathtaking sphere of visibility is not the universe. It is only the part of the universe that has revealed itself to us. If you imagine yourself standing within a globe of ancient starlight, you begin to sense the quiet beauty of this idea. The universe might be boundless, yet our window into it is small, fragile, and shaped entirely by how far light has had time to travel. That is the real edge, not a wall, not an ending, but a moment in time made visible. So perhaps as you drift deeper into the night, you might consider this gentle truth. The edge of the universe, as most people imagine it, is simply not there. What exists instead are layers of understanding, layers of perception, and layers of light. And each time we peel one away, another waits beneath it, stretching into distances we can feel but cannot yet see. And well, now that we have softened the idea of the cosmic edge itself, it becomes natural to ask a quieter, more intimate question. If the universe has no physical boundary, then what exactly is this horizon we keep hearing about? What is this invisible threshold beyond which even the fastest light will never reach us? Perhaps, in the dim glow of the next chapter, we can walk toward that horizon together and see what it truly means to live inside a universe where the farthest edge is not a place, but a limit set by time itself. Well, you see, as we leave behind the question of whether the universe has a true physical boundary, we step into something far subtler and perhaps even more haunting. If the universe itself has no wall, no final edge you could ever sail toward, then what is this boundary scientists speak of, this quiet limit beyond which we cannot see? And, perhaps the simplest way to ease into it is to remember that everything we know about the cosmos arrives to us through light. Light is our messenger, our historian, our bridge to the past. And that is the thing. The edge we speak of now is not a place, but a moment. Scientists call this region the observable universe. It is not the whole universe, but only the portion from which light has had enough time to reach us since the cosmos first grew luminous. And you know, when we say light travels fast, we mean unimaginably fast. But even so, it is not infinite. It does not leap instantly across the vastness. It must cross the darkness steadily, patiently, like a runner on an endless track. That travel time becomes a boundary, a limit, a kind of cosmic echo chamber in which only the oldest and most persistent light can be heard. And, perhaps this is the most poetic truth of all. The farther we look out into space, the deeper we gaze back into time. You and I cannot simply look outward and see things as they are right now. We see them as they were when their light began its journey toward us. A star 10,000 light years away shows us its 10,000-year-old self. A galaxy billions of light years away shows us a version of itself so ancient that it may not exist in the same form anymore. Each distant point is a time capsule, a memory suspended in light. So when we speak of the observable universe, we are not describing a spatial bubble. We are describing a temporal one, a sphere of time centered on us, defined not by geography, but by history. Everything inside it is something whose light has had time to arrive. Everything outside it remains hidden, not because it is unreachable, but because its photons have not yet completed the long pilgrimage across expanding space, and expansion is the key, you see. If the universe were static, the observable universe would simply grow larger as time passed. Light would arrive from farther and farther away, and one day we might see almost everything. But the universe is not static. It is stretching. Space itself expands, and that expansion alters the path of light. The farther something is from us, the faster it appears to recede, carried by the swelling fabric of space-time. There are places where that recession speed becomes so great that even light cannot overcome it, not even if it had infinite time. Imagine throwing a message into a river whose current grows stronger with distance. At some point, the message is swept away faster than it can drift back toward you. That is what cosmic expansion does to light. And so we arrive at a quiet but profound consequence. There are regions of the universe we will never see, not now, not in a million years, not in the entire future history of humanity or whatever we may become. These places send out light, but the expansion of space ensures that light will never bridge the gap. Entire galaxies, entire clusters, entire cosmic webs drifting outward, beyond reach, beyond visibility. They exist, they play their roles in the vast cosmic symphony, but for us, they are ghosts without faces. And, it is humbling, is it not? To realize that the observable universe is not the universe. It is only our window, a sphere roughly 46 billion light-years in radius, astonishingly large to our human senses, yet possibly small compared to the true enormity of all that exists. The real universe might be hundreds of billions of light-years across, or trillions, or infinite. We do not yet have the means to know. What we have is our glowing bubble, our fragile bubble of visibility, defined by the finite speed of light and the age of the cosmos. And well, when we say the observable universe is about 46 billion light-years in radius, we are actually saying something deeply counterintuitive. The universe is roughly 13.8 billion years old, so you might expect the edge of visibility to be 13.8 billion light-years away. But expansion stretches space faster than time alone would allow. Light that has traveled for the entire history of the cosmos finds itself carried along by the expansion, meaning its origin point is now far farther than the number of years multiplied by the speed of light. It is almost as though space-time itself has been breathing beneath the light, expanding with every passing moment, carrying the past outward even as its echoes race toward us. Perhaps this is the most beautiful contradiction of all. The light we see now began its journey from sources far closer than they are today. When we catch the faint glow of a galaxy from the young universe, we are not seeing its present. We are seeing a fossil, a memory, and the galaxy itself has long since moved on, carried away by the cosmic tide. In this sense, the observable universe is a museum built entirely from delay. Every exhibit is ancient. Every detail is a relic. And, as strange as it may sound, this means that what we call the edge of the observable universe is not the edge of anything physical at all. It is merely the farthest point from which light has been able to reach us since the moment light first existed. But there is another twist. Before the universe cooled enough for light to travel freely, everything was hidden behind a dense fog of plasma. Light could not escape. It was constantly scattered. The earliest electromagnetic whisper we can detect is the cosmic microwave background, a soft afterglow from a time when the universe was only a few 100,000 years old. Beyond that curtain, light becomes unreachable. Even if we imagine looking farther, no electromagnetic signal remains. And so the observable universe is doubly bounded, once by the age of the cosmos itself, and again by the moment transparency began. It is as though we are standing at the shoreline of time, and beyond that horizon lies an ocean we cannot pierce with light, not because nothing exists there, but because light has never had the chance to carry its story to us. Yet we must also reckon with a quieter truth. The farther out we look, the more distorted everything becomes, distorted not by instruments but by space-time itself. Expansion stretches wavelengths, turning brilliant starlight into faint microwaves. Shapes warp, colors fade, time slows to a near standstill from our perspective, and eventually there is a limit beyond which even the faintest echo cannot reach us, not because the light is not there, but because the universe stretches it into oblivion. And well, once you begin to think of the observable universe in this way, it becomes hard not to feel a certain tenderness toward it. A sphere of light wrapped around us, not centered on any cosmic privilege, but centered simply on our location in space and time. Every observer anywhere in the cosmos would have their own observable universe, their own bubble, their own horizon of knowable things. And that means there is no single universal boundary, only countless local ones, each defined by the eyes that gaze outward. Perhaps this is what makes the concept so intimately human. The observable universe is not a feature of reality alone. It is a feature of experience. It reminds us that everything we know, everything we measure, everything we admire in the night sky is filtered through time, distance, and the unyielding speed of light. And there is something quietly stirring in that realization. Because once we understand that our view is bounded, we begin to ask what lies beyond. Not in a whimsical sense, but in a deeply scientific one. What happens at the very edge where light fades into silence? What lies just beyond the perimeter of visibility? And how does cosmic expansion shape that unseen territory? Questions like these lead us gently toward the next idea, the next veil we must lift if we want to truly understand the nature of the edge. If the observable universe is defined by what light can reach us, then the next chapter asks an even stranger question. What happens to the regions whose light will never reach us? What kind of boundary is created by expansion itself, not by time? Well, perhaps we can step toward that invisible frontier together, into a place where the universe builds not walls of matter, but horizons of light, and see how this subtle and shifting edge shapes the story of everything we can know. Well, you see, once we have accepted that the observable universe is shaped not by walls but by the reach of light itself, a new and stranger kind of boundary reveals itself. And, perhaps this is where the story becomes truly mesmerizing, because the next edge we encounter is not drawn by matter or energy or even time, but by the relentless expansion of space-time. It is an edge that surrounds us constantly, invisibly, silently, like a thin veil draped around our cosmic viewpoint. Scientists call it the horizon, though it behaves nothing like the gentle horizon we see on Earth. This one is sharper, more unforgiving, more absolute, defined by the interplay between light and expansion. And, when we speak of horizons in cosmology, we are really speaking about limits on communication. A horizon marks the divide between the regions that can ever touch us with their light and the regions forever slipping away. If the observable universe is the sphere of what already has reached us, then this horizon is the sphere of what can still reach us in the future. It is a living boundary, shifting with time, determined not just by how far light can travel, but by how fast the universe itself stretches beneath it. And well, here is where the universe becomes almost painfully poetic. Imagine yourself standing in the center of a dark ocean. The water around you is calm, but very slowly, almost imperceptibly, the ocean begins to swell. The farther away a piece of driftwood lies, the faster it drifts from you, not because of its own motion, but because the sea itself carries it away. Give it enough distance, and the driftwood will move faster than any swimmer could ever pursue. That is what is happening to distant galaxies. It is not that they are flying through space at incredible speeds. It is that the fabric of space itself is expanding so rapidly that beyond a certain distance, nothing can overcome the flow. And this is where the cosmic horizon forms. It is the distance beyond which light, no matter how determined, can no longer make progress toward us. Not because it lacks speed, but because space-time itself is sweeping its starting point away faster than the light can close the gap. The photons are like runners on a treadmill that keeps accelerating beneath them. No matter how much effort they pour forward, the ground stretches away faster still, and so their story never reaches us. Perhaps the most haunting truth is that some galaxies, ones we can see right now in the faint depths of our telescopes, are already beyond this horizon. We are looking at their past selves, frozen in ancient light, even though their present selves have slipped beyond the cosmic point of no return. Their photons from this moment onward will never reach Earth, not in 1,000,000 years, not in 1,000,000,000,000. They drift away into darkness, not because they vanish, but because the expanding universe quietly draws a curtain over them. In the decades following early observations and continuing into the years around 2025, astronomers have watched more and more galaxies fade beyond this reach, not by growing dimmer, but by being carried away. And, I suppose this is one of the strangest lessons in all of cosmology. We live inside a shrinking island of the knowable universe. Not shrinking in size, but shrinking in connection. The horizon defines what can touch us in the future. And as expansion accelerates, the reach of our future knowledge shrinks. The more the universe expands, the more isolated our cosmic neighborhood becomes. Galaxies that once shared the same cosmic stage are slowly disappearing behind the veil, leaving only their fossilized images in the light that did manage to escape before the horizon closed over them. This effect gives rise to a deeply emotional image, a universe full of islands drifting apart, each island carrying its own history, its own structures, its own stories, slipping further and further from one another across the swelling ocean of space-time. And someday, far in the cosmic future, the only galaxies left visible from Earth or any descendant civilization would be the ones gravitationally bound to us, the ones caught in the same gravitational well. Everything else will be carried so far beyond the horizon that their light will be permanently unreachable. But perhaps the most extraordinary part of this horizon is its nature as a one-way boundary. It is not a physical wall you could touch or approach. It is instead a mathematical line describing the dynamic relationship between velocity, distance, and expansion. If you could travel outward at tremendous speed, surpassing even light itself in some hypothetical future framework, you might imagine you could slip across this horizon. But the horizon is not fixed. As you move, it moves. Always just far enough away that you can approach it but never cross it. It is a border that recedes eternally, a mirage drawn by the rate of cosmic acceleration. In this sense, the horizon behaves like a cosmic lighthouse. It is not a place, it is an effect, an inevitable result of how space-time changes, and that means this invisible sphere is not something the universe built intentionally, but something that emerges naturally from the rules governing it. A horizon is the universe whispering to us, telling us that there are things we will never know. Not because they are hidden, but because the structure of reality prevents their stories from ever arriving. And, you might wonder why some galaxies seem to disappear entirely from view, not just fade, but slip away. Part of the answer lies in how expansion stretches the wavelengths of light. As a galaxy drifts closer to the horizon, the light it emits is stretched by expansion until its waves become too long, too faint, too soft to detect. What once was visible starlight becomes infrared. What once was infrared becomes microwave. And eventually the light is stretched so completely that it is undetectable by any instrument we could build. The galaxy does not disappear in a dramatic flash. It dissolves into invisibility, softened by the slow stretching of time itself. This stretching is called redshift, but perhaps that word is too modest for what it represents. Redshift is not simply a shift in color, it is a transformation of information. A distant galaxy's light becomes a message whispered across billions of years. Space-time pulls at it like a slow tide, stretching it thinner and thinner until at last it vanishes into silence. We do not witness the disappearance, we only feel it in the absence. And well, once a galaxy crosses that threshold beyond which its light will never reach us, we can no longer interact with it in any meaningful way. It has left our observable future. There is no signal, no particle, no gravitational influence that can bridge the gap. Even gravity itself, which travels at the speed of light, is subject to the same rule. The horizon does not merely block what we see, it blocks what can physically affect us. The universe becomes partitioned into causal islands, each defined by its own cosmic horizon. This idea, sometimes called the cosmic event horizon, is one of the most radical implications of an accelerating universe. It suggests that we live in a space-time where the reach of influence is not universal. Not all regions of the cosmos can communicate with one another, even if we imagine civilizations billions of light years away, sending messages with perfect precision, aiming them directly at us. The majority of these messages will never arrive, not because they were not sent, but because the fabric of reality itself forbids their passage. You see, Horizons are not unique to cosmology. They appear in other places in physics too. The most famous example is the horizon of a black hole, the boundary beyond which even light cannot escape the gravitational pull. Although the mechanism is different, the analogy is stirring. In both cases, there is a region from which no information can reach an observer. In the case of a black hole, the cause is gravity. In the case of the universe, the cause is expansion. And yet the horizon around us is in some ways more enigmatic, because unlike a black hole's event horizon, our cosmic horizon is not a fixed surface with an absolute meaning. It depends on where we stand. Every observer in the universe has their own horizon, their own sphere of influence, their own boundary between the reachable and the unreachable. It is deeply personal, almost intimate, shaped by their position in space-time. This personal horizon shifts as the universe expands. It is not static. It grows or shrinks depending on the rate of acceleration. In the far cosmic future, the horizon will contract in such a way that only the closest structures remain visible, while everything else drifts beyond the line. The sky will grow emptier, quieter, lonelier, and even though expansion is silent, it will carve an emptiness more profound than any sound could reveal. And perhaps the most philosophically striking aspect of this horizon is that it limits not only what we can see, but what we can imagine. There may be entire realms beyond our cosmic boundary, realms teeming with galaxies, structures, phenomena, perhaps even forms of matter or physics we have never encountered, but their stories will never arrive. Their light will never cross the invisible border. Their existence will remain forever unconfirmed, preserved only as mathematical possibility or philosophical speculation. And once we accept this, we also uncover a subtle shift in perspective. The horizon is not a tragedy. It is a reminder that the universe is larger than our reach, and that knowledge is always bounded by the possible. It teaches us humility, showing that even with the greatest instruments ever built, even with telescopes orbiting in the silent void, or instruments forged in the years around 2025 that push detection near its limits, we will never see the full stage on which the cosmic drama unfolds. But the horizon is not merely a boundary of sight. It is a boundary of time. The galaxies that have crossed this cosmic line have not simply moved away. They have moved into a future we will never share. Their present has slipped beyond our future. It is as though the universe holds separate timelines, each drifting apart so slowly we only notice it on scales far beyond a human lifetime. So the horizon is both an ending and a beginning. It is the end of what we can observe. It is the beginning of a vast, unseen universe that continues outward into mystery. And perhaps the deepest irony is that the horizon itself is shaped by the same expansion that allows the cosmos to evolve, to cool, to form stars, and to build the galaxies we admire. The universe hides from us using the same force that gives it life. And well, you might wonder where this leads us next. If the horizon marks the boundary between what we can ever observe and what will forever remain hidden, what does that imply about our position here, about the history that has already reached us, about the earliest light that still glows faintly from a time when the universe was young, fragile, newborn? Perhaps to understand the horizon fully, we must also look backward, toward the earliest light the universe ever released, the faint whisper that still surrounds us even now. And so, as we drift further into this quiet cosmic story, the next chapter invites us to explore that ancient glow, the first light, the oldest message, the delicate radiation that forms the baby picture of the universe itself. A light so primordial, so soft, that it reveals what the cosmos looked like long before stars ever shone. Well, you see, as we follow the thread from that ancient whisper of first light, another question drifts quietly into view, one that has puzzled thinkers for generations. If the universe has a horizon around us, does that not imply we stand somewhere special, somewhere central? And, perhaps this is where our intuition gently misleads us again. Because when people imagine the universe expanding, they often picture it as an explosion, a fireball erupting outward from a single location, flinging galaxies in every direction. And if that were true, well, there should indeed be a center, a point of origin, a cosmic birthplace marked somewhere in space. But that image, charming as it is, distorts the nature of the Big Bang completely. It turns a transformation of space-time into something like fireworks in the sky. And fireworks always have a center. They burst outward from one luminous puncture. The universe, however, did not erupt into space. It brought space with it. The Big Bang happened not at a point inside a larger emptiness, but everywhere at once. Every region of space today was already present then, though compressed into a far denser, hotter state. The expansion we see now is not galaxies rushing away from some central explosion. It is the fabric of space itself stretching, carrying all things with it. And you know, the moment we let that idea settle, something beautifully counterintuitive begins to take shape. If expansion occurs everywhere, then no point can claim to be the middle. There is no privileged seat in the cosmic theater. Every galaxy, every cluster, every small island of stars can look outward and see all others rushing away, each one able to declare with equal honesty, "I appear to be at the center of expansion." And this is not an illusion in the deceptive sense. It is simply a consequence of uniform expansion. When all distances increase simultaneously, every observer sees themselves as central to the unfolding of space. Perhaps a simple metaphor will help here. Imagine drawing dots on a balloon. As the balloon inflates, each dot sees all the other dots moving away. No dot is special. No dot occupies the center. The center of expansion is not on the surface at all. It lies outside the balloon's two-dimensional world. In our case, the universe does not expand into anything external, so even that metaphor must be used carefully. But it illustrates the essential truth. Expansion does not grant any location the honor of centrality. And well, many people still cling to the intuitive picture of a center because we think in terms of explosions. But the cosmos did not explode into space. It expanded as space. The early universe was not a ball of matter surrounded by emptiness. It was an entire space-time, dense and uniform, stretching outward in every direction simultaneously. There was no outer border to expand into, and if there was no outside, then there could be no center. Now, you might wonder, if there is no center, why do we see galaxies fleeing from us? Why not some drifting toward us? Why this symmetrical retreat? And the answer lies in the remarkably uniform structure of the cosmos on large scales. The universe, averaged across vast distances, looks nearly the same in every direction. No region is privileged. No corner is denser than the rest. And because expansion acts uniformly, each region watches all others recede. Even galaxies far across the cosmos see the same pattern. If we were to magically transport ourselves to a distant cluster, we would find the galaxies around it fleeing precisely as ours do from us. This uniformity is not merely an observation. It is a foundational element of modern cosmology. It tells us that the universe has no center in space, only a center in time. The Big Bang was the beginning everywhere, not the beginning at a point. And you know, this is one of those places where science gently corrects our deepest intuitions. We humans instinctively draw maps with origins. We stand on Earth and can point to where something began, where something ended, where something is located. But the universe does not bend itself to our instincts. Its structure is stranger, softer, more symmetrical. It asks us to imagine a reality where every vantage point is equally valid, equally central in its own expanding domain. And, this is where we begin to see why the idea of a central position in the cosmos carries a kind of philosophical weight. For centuries, humans believed they were physically at the center of creation. Then we discovered Earth is not the center of the solar system. The solar system is not the center of the galaxy. The galaxy is not the center of the universe. And now cosmology reveals an even more radical truth. There is no center at all. Not for us. Not for anyone. If that thought feels disorienting, perhaps that is precisely its beauty. It frees us from the burden of centrality. It tells us we do not occupy a special throne in the architecture of existence. Instead, we are woven into a fabric that stretches uniformly, a participant rather than a ruler, a witness rather than a landmark. And well, the more deeply we look into the cosmic microwave background, the earliest light of the universe, the more strongly this conclusion is supported. That ancient radiation is nearly the same in all directions, varying only by tiny ripples that seeded galaxies long ago. If the universe had a center, or if we were drifting significantly off-center, those patterns would betray the asymmetry. But the patterns remain consistent, soft, and subtly balanced. They tell us that the universe grew uniformly, that we are not on the edge of some cosmic bubble, nor offset from some privileged coordinate. We are simply part of the whole. And perhaps the most beautiful thing is that even though the Big Bang happened everywhere, we often speak of it as though it happened long ago in a distant place. But that distance is not spatial. It is temporal. The Big Bang lies behind us in time, not around us in space. Every galaxy carries the memory of that beginning, and each galaxy recedes from every other because they all share that mutual origin. The universe is like a great tapestry. No point on the cloth is more the beginning than any other. The beginning lies in the weaving itself. And yet, despite this symmetry, each observer experiences the cosmos as though they are standing at the center of their own observable universe. You look outward and see galaxies arranged in a roughly spherical shell around you, but the galaxy in the next cluster sees the same pattern, and the galaxy 200 million light years beyond that sees the same pattern again. The observable universe is always centered on the observer, not because of any physical value placed on their position, but because light reaches each vantage point symmetrically. That is the quiet paradox here. Everyone sees themselves at the center of what they can observe, yet no one is the center of the universe. It is a kind of cosmic humility encoded into the laws of physics. And, if all of this seems to pull the ground out from beneath our sense of place, perhaps that is exactly what the universe is inviting us to feel. It invites us to imagine a reality without fixed points, without privileged positions, where everything expands from everything else. A place where center is not a location, but a perspective. And in the years around 2025, as our telescopes refine their sensitivity and map cosmic structures with greater detail, this picture only becomes clearer. The universe expands evenly on the largest scales. The filaments and voids, though intricate, do not favor any grand axis or core. Instead, they form an astonishing cosmic web that stretches outward in every direction with no sign of an origin point in space. And well, this makes us ask the next natural question. If the universe has no center, what lies beyond the farthest thing we can possibly observe? If everything expands uniformly and no position is special, then what occupies the realms that even the earliest light cannot reach? What could be happening in the vast unseen domains beyond our cosmic horizon? And perhaps, to explore that question properly, we must step beyond the comfortable limits of observation. We must consider regions where no light has arrived and may never arrive, a place where the universe does not end, but where our knowledge thins into mystery, a place not bounded by walls, but by information itself. So, as we drift onward, the next chapter invites us to peer gently into that unseen territory, to wonder what lies beyond the observable universe, and what it means to speak of a cosmic edge that is not a location, but a boundary between the known and the unknowable. Well, you see, once we accept that the universe has no center, that the Big Bang unfolded everywhere at once, and that every galaxy shares the same cosmic heritage, a deeper and more delicate question begins to stir. If there is no middle, then what lies beyond the edge of what we can see? And, this is where our imagination stretches against its own limits, because the very phrase beyond the observable universe sounds like the beginning of an adventure, as though beyond that boundary lies some new territory waiting for explorers with sturdy boots and brighter lanterns. But perhaps the truth is softer, stranger, and more elusive. It is not a frontier of space. It is a frontier of knowledge. When we talk about what exists beyond the observable universe, we are not describing a region separated from us by walls or by voids. It is not another realm stitched onto ours like a neighboring kingdom on an old map. It is simply more universe, more galaxies, more stars, more structures woven into the cosmic fabric. And you know, the only thing that makes them unreachable is that their light has not yet had time to reach us, and in many cases will never reach us because expansion has pushed them away faster than their light can close the distance. And perhaps this is the most humbling truth. The observable universe is not the whole universe. It is only the part that has revealed itself to us. Beyond that sphere of ancient light, there might be countless more galaxies, superclusters, filaments, and voids. There might be architectures of matter we have never seen, but there is no data from that territory. None. No photons, no gravitational whispers, no messenger of any kind. And so, even in the years around 2025, our best cosmological models must navigate that silence with mathematics rather than measurement. And, well, this brings us to an idea that often surprises people. The boundary of the observable universe is not a physical edge of existence. It is simply the limit of information, a place defined not by what is there, but by what can reach us. It is like trying to read a book whose pages continue far beyond the ones printed in ink. The story extends outward, but the visible words stop. The cosmos keeps going, but the light cuts off, and so our picture of the universe is inevitably incomplete. Some might imagine that beyond this boundary lies a kind of void, a blank expanse untouched by galaxies. But the laws of physics offer no support for such emptiness. Everything we know about the structure of the cosmos suggests that what lies beyond is likely similar to what lies within. More cosmic web, more immense strands of galaxies, more shimmering clusters suspended in the dark. The universe does not become stranger at its outskirts. It simply becomes unreachable. And yet, if we cannot observe this region, how can we speak of it at all? How can science stretch its fingers into places where no light will ever flow? Well, you see, here is where cosmology becomes a subtle dance between evidence and inference. We know that, on large scales, the universe is remarkably uniform. The cosmic microwave background, the faint afterglow from the early universe, tells us that matter was distributed nearly evenly everywhere. The tiny fluctuations in that radiation predict the patterns of galaxies we see today. And when we measure galaxies across enormous slices of space, their distribution follows the same general rules. Random, but not chaotic. Structured, but not patterned. Complex, but not irregular. That uniformity gives us permission to assume, cautiously, that the universe beyond our observable sphere likely resembles the universe within it. Not identical, but statistically alike. If you stand in the middle of a vast forest and every direction shows trees stretching beyond sight, you are justified in assuming that more forest continues where your eyes cannot follow. In that same spirit, we assume the cosmos continues, and perhaps the most interesting tension here is between what we can imagine and what we can measure. No experiment can ever reach beyond our cosmic horizon. No future telescope, no matter how clever or powerful, can extract information from regions permanently sealed off by expansion. The boundary is absolute, not technologically but physically. Light from beyond it cannot ever reach us, not even in principle, not even in the far distant future when the universe grows old and quiet. So, in a sense, the edge of the observable universe is like a curtain, not a wall, not a barrier, but a veil drawn by time and expansion. On our side of the curtain, the cosmos plays out its intricate story of galaxies forming, merging, and drifting into the dark. On the other side, the story continues, but the script is hidden from us. The universe is under no obligation to reveal its full shape to any particular observer. Now, you might imagine, well, what if there is something radically different out there? What if beyond the observable universe lies a region governed by different physical laws, different constants, different particles? And this is where science treads carefully. There are models that allow for variation, but there is no evidence for them. There is no data. The horizon isolates us. And because of that isolation, we cannot confirm nor deny such possibilities. What we can say is this: if the rules of physics were dramatically different, beyond our cosmic horizon, we would expect to see distortions in the visible universe, ripples in the cosmic background, irregularities in galaxy formation, strange asymmetries. But the observable universe appears strikingly uniform. It behaves as though the physics we know applies everywhere. That does not prove the entire cosmos is the same, but it strongly suggests continuity, at least across regions near enough to influence us. And well, perhaps the most poetic way to think about this is to imagine that the universe is far larger than our visible bubble, so large that the observable region is merely a minuscule patch of an immense, unbroken whole. If the entire universe were a vast ocean, our observable universe would be nothing more than the water inside a single ripple expanding outward from a single point. The ocean does not end where the ripple fades. Our knowledge does. And yet, even though we cannot observe beyond the horizon, we can still theorize about that unseen territory. Some cosmological models propose that the universe might be curved, looping back on itself so subtly that the curvature is undetectable within our visible region. Others propose that the universe might be infinite, extending without end in every direction. Both possibilities are consistent with current observations. And that is the thing. Beyond the horizon, multiple truths can coexist as long as they do not contradict the data inside it. There are also models, speculative, yes, but thoughtfully constructed, that propose regions beyond our observable horizon might differ in density or structure. Maybe other patches of the early universe developed slightly differently. Maybe inflation, the incredible burst of expansion in the universe's earliest moments, created pockets of space-time with distinct properties. These patches would be causally disconnected from one another, forever separated by horizons. Our entire observable universe might be just one such pocket. But again, these ideas remain beyond the reach of verification. And this is the quiet tension that defines cosmology. We long to understand the whole, but we are confined to a bubble of visibility. The universe beyond that bubble is not forbidden, but it is mute. So we speak of it cautiously, gently, with humility. Another fascinating implication emerges when we remember that the boundary of the observable universe is expanding. As time passes, light from more distant regions reaches us. Our visible bubble grows. Regions once hidden might drift into view, but expansion also accelerates, meaning that some regions will forever remain unreachable. The observable universe grows, but the truly accessible universe, the part from which light will eventually reach us, shrinks. It is a paradox woven into the fabric of space-time. This means that the universe beyond our horizon is, in some sense, dynamic from our perspective. It influences the edge of what we can know, shaping the boundary of our cosmic portrait, and yet it never fully enters that portrait. It remains the silent frame around our field of vision. And well, when people ask what lies beyond, they often imagine that stepping across this edge would reveal something dramatic, something fundamentally different. But cosmology's strongest insight is that what lies beyond is not a different kind of universe. It is simply more universe, more of the same expanding fabric, more of the same cosmic web, more of the same physics that governs everything we can see. The edge is not a frontier where the universe changes. It is a frontier where our knowledge fades. So, perhaps the deepest truth here is that the observable universe is not a cosmic container with walls. It is a bubble of information defined by the interplay of light, time, and expansion. And everything beyond that bubble is not beyond existence. It is beyond communication. The universe does not hide itself maliciously. It simply obeys the rules that govern it. And yet, as soft as that truth is, it invites an even more mysterious question. If the observable universe is wrapped in a veil of unreceived light, and if beyond that veil lies a vast territory of unobservable galaxies, then what connects us to that earliest light we can observe? What message reaches us from the dawn of time, crossing the ages to paint the universe's first portrait, the faint and ancient glow that marks the earliest moment we can ever see? Well, perhaps to answer that, we must turn toward the next chapter, into the gentle radiance of the cosmic microwave background, the infant light of the universe itself, still whispering through the darkness after billions of years. Well, you see, if we stand at the edge of what we can observe and gaze outward toward the dimmest and most ancient light the universe allows us to witness, we find ourselves looking not into space, but into time itself. And perhaps this is where the story becomes strangely intimate, because the next thing we encounter is not a galaxy, not a star, not even a wisp of cosmic gas, but the universe's own childhood, the earliest light, the faint glow that has been traveling toward us for nearly the entire history of existence. It is the last, oldest, most fragile message the cosmos can send before darkness takes over completely. Scientists call this glow the cosmic microwave background, but that name feels almost too clinical for something so profound. In truth, this light is a relic from a moment when the universe was still an infant, only a few 100,000 years old. Before that time, the cosmos was too hot, too dense, too chaotic for light to travel freely. Photons were trapped in a swirling fog of charged particles, bouncing endlessly, unable to break free. It was a cosmic storm of fire and opacity, a universe without transparency, without stars, without galaxies, without any structure at all. And then something beautiful happened. The universe cooled. Just enough. Suddenly, electrons and protons could cling together to form the very first atoms. And when that happened, the fog lifted. Light, for the first time, could travel. It streamed outward in every direction, flooding the cosmos with a radiance that has been journeying ever since. That light is still here today, washed thin by time, and stretched by expansion into microwave wavelengths, but unmistakably present. When we tune our instruments correctly, the whole sky glows faintly with it, a whisper from the beginning, the universe's first breath preserved as a shimmering echo. And you know, this ancient light is often described as the earliest photograph of the universe. Not a photograph in the modern sense, of course, but a snapshot of conditions frozen in time. The cosmic microwave background captures the universe at the moment it first became transparent, when it was still a warm sea of hydrogen and helium atoms, with slight ripples in density that would one day grow into galaxies, clusters, the great cosmic web itself. These ripples appear as tiny temperature variations in the background, minute patches slightly warmer or cooler than the average. These faint temperature ripples, only millionths of a degree in magnitude, contain the blueprint of everything that would later form. They show where matter pooled, where gravity tugged harder, where seeds of structure quietly gathered. They are cosmic fingerprints, intricate and delicate, revealing how the universe's architecture was set into motion. And well, perhaps the most astonishing part is that these ripples are not random in the chaotic sense. They follow a specific pattern predicted by physics, by quantum fluctuations stretched across vast scales during the universe's earliest moments. When you look at the cosmic microwave background, you are not just seeing ancient light. You are seeing the earliest evidence of structure, the memory of a universe still learning how to become what it is today. And in those tiny fluctuations, you find the faint imprints of sound waves that once rippled through the primordial plasma. Yes, sound waves, acoustic oscillations ringing across the early cosmos like vibrations in a vast celestial drum. They left behind patterns we can still measure with exquisite precision. And perhaps that is one of the most poetic truths hidden in this ancient glow. The universe carries within it the echoes of its own infancy. The light we see is infused with the story of those early vibrations, encoded in the subtle distribution of hot and cold patches. These patterns tell us how fast the universe was expanding, how much matter it contained, how dense it was, how curved space might be. They allow us to peer not only into the earliest visible moment, but into the physics that shaped everything before and after. This is why cosmologists often describe the cosmic microwave background as a Rosetta Stone for the universe. It translates the chaotic birth of space-time into numbers we can read, patterns we can measure, predictions we can test. Even in the years around 2025, as our detectors grow more sensitive and maps of the background become increasingly detailed, we continue to uncover new insights. The early universe is an open book, written in radiation. But the light itself, the light that left the primordial universe, has not aged gracefully. It has been stretched mercilessly by expansion. Originally glowing in brilliant visible and infrared wavelengths, it is now chilled into microwaves, 1 billion times less energetic. If you could somehow see it with your own eyes, it would appear as a soft, omnipresent glow across the whole sky, almost uniform, almost featureless, yet humming with subtle variations that tell the story of everything. But because the wavelengths have stretched so much, we need special instruments, cooled to near absolute zero, to detect its faint warmth. And there is something almost heartbreaking in the idea that this is the last surface of the universe we will ever see. We cannot look further back in light because before this moment there was no free light to see. The universe was opaque. Photons could not travel. The cosmic microwave background is the final wall of electromagnetic information. Beyond it lies a deeper darkness, not because nothing existed, but because light has no memory of that time. Yet this boundary is not a limitation of imagination. It is a physical truth. It marks the earliest possible moment from which light can reach us. It is a wall of time, a horizon as real as the edge of the observable universe, but drawn not by distance, but by physics. The moment the universe became transparent is as far back as light can take us. To see beyond it, we would need a different messenger, gravitational waves perhaps, or neutrinos from the earliest era. Some of those signals may still be out there, drifting through the cosmos, waiting for detectors sensitive enough to listen. But even if we can never see before that moment with light, what we do see is astonishing. The cosmic microwave background is not merely the first light, it is also the oldest fossil we possess. It reveals the conditions of the early cosmos with extraordinary clarity. Its temperature, its density variations, its uniformity, its tiny imperfections. This ancient glow shows us that the early universe was almost perfectly smooth, yet not completely. The tiny irregularities, those subtle temperature ripples, became the seeds of galaxies. Without them, no stars would form, no planets, no life, no observers wondering who they are in the grand architecture of the cosmos. And perhaps the cosmic microwave background is remarkable, not for what it shows us directly, but for what it implies. It tells us the universe has a consistent history. It tells us that matter and energy evolved according to the same rules everywhere. It tells us that the large-scale structure of the universe grew from small, quantum-sized imperfections. It tells us that the very earliest conditions were incredibly hot and dense, but governed by knowable physics. It also tells us about the fate of the universe, because the spectrum of this ancient radiation, its exact distribution of frequencies, reveals how the cosmos is expanding today. It confirms that space is stretching faster now than in earlier epochs, driven by a mysterious force we call dark energy. It whispers to us not only of the past, but of the future, pointing toward a universe that will continue expanding forever, cooling ever more, dimming into eventual quiet. And if you listen closely to this ancient light, there is something else hidden there. Something faint, delicate, and profoundly important. Tiny distortions, nearly swallowed by noise, that hint at gravitational waves from the earliest moments of the universe. Ripples in space-time caused by inflation itself. These patterns are so subtle that we are still searching for them, combing through the cosmic microwave background with increasing precision. If someday we find them, we will have touched the echo of the universe's birth, the earliest moment physics can describe. we will have glimpsed a fleeting fingerprint left by the universe before it was even a second old. And yet, even with all this beauty, the cosmic microwave background is a limit, a soft, glowing wall. Beyond it lie eras of cosmic history, forever hidden from electromagnetic sight. It reminds us that even the universe's oldest light is only a fragment of the story. There are regions of existence we cannot access through photons at all. So, after tracing this ancient light, after listening to the whispers of the universe's infancy, we find ourselves pulled toward a bigger question, one that touches the very structure of reality itself. If the cosmos began in such a uniform, predictable way, then how large is it truly? How far does it extend beyond our observable bubble? And is space infinite? Or does it curve back on itself in ways that defy our everyday intuition? Perhaps to explore that, we must let go of the comfort of boundaries entirely and ask whether the universe ends anywhere at all, or whether it stretches forever, without edges, without endpoints, without limits in space. So let us drift toward that next horizon, into the question of infinity, where space becomes not a place, but a possibility. Well, you see, once we've absorbed the soft, ancient glow of the universe's first light, once we've listened to those faint ripples that whispered the blueprint for galaxies and stars, and eventually for us, a larger and perhaps more unsettling question rises slowly into view. If that light comes from the farthest moment we can ever see, and if beyond that lies a vast realm of silence, then how far does the universe itself extend? Does it end somewhere? Does it fold back on itself? Or does it stretch outward forever into a boundless expanse where there is no edge, no border, no final frontier at all? And this is where our human intuition, shaped by landscapes with horizons and roads with endings, begins to falter. Infinity is not something we are built to grasp easily. We live in a world of boundaries. Rooms have walls. Oceans have shores. Books have last pages. Yet when we talk about the universe, the very stage upon which all those bounded things exist, the idea of an edge becomes strange, perhaps even meaningless. Cosmologists have long wrestled with this question: is the universe infinite or finite? And the truth, you see, is that even now in the era around 2025, we simply do not know. The observable universe is finite, of course, a sphere determined by the reach of light. But that sphere tells us nothing about the total. It might be a tiny bubble within something much larger. It might be one patch of a universe so immense that infinity becomes not a number, but a state of being. When scientists consider the possibility of an infinite universe, they are not imagining something in the abstract philosophical sense, but something grounded, measurable, testable through the geometry of space-time. If the universe is perfectly flat, if space itself is not curved inward like a sphere or outward like a saddle, then one natural solution is that it extends forever in every direction. Flatness implies infinity, or at the very least, a scale so vast that any curvature is too subtle for us to detect. And you know, measurements of the cosmic microwave background reveal something remarkable. The universe appears to be extraordinarily flat, at least within the observable region. As far as we can map, the fabric of space-time does not curve significantly. Lines that should bend if space were finite remain, for all practical purposes, straight. That flatness tempts us toward the idea of an infinite cosmos. But then comes the gentle caution. What we observe is limited. Flatness might persist across the entire universe, or it might only be local, like standing on a small patch of Earth and concluding the whole planet is flat because the ground beneath your feet does not curve. The observable universe is simply not large enough to make definitive claims. And well, this leads us to the second great possibility. Maybe the universe is finite, but without edges. Imagine the surface of a sphere. It has finite area, but no boundary. You can walk forever without encountering a wall, and yet the terrain is limited. Space itself could be something like that, though not in 2 dimensions. It could wrap around in ways we cannot visualize easily, looping back on itself through higher dimensional shapes that defy everyday experience. You could travel in a straight line, never changing direction, and eventually return to your starting point, yet never meet an edge along the way. This idea often makes people pause. How can something be finite but without borders? But the universe does not owe us forms that match our intuition. It only owes us the truth of its own geometry. And that geometry may be curved just enough to fold space elegantly upon itself. If so, the curvature is gentle, so gentle that our instruments cannot yet detect it. A universe like this would be immense, but not infinite. A grand, seamless shape with no outside, no boundary, and no ending. And yet, a third possibility lingers. The universe might be both infinite and curved in strange ways. Some models describe exotic topologies, spaces connected in patterns that resemble labyrinths, corridors, or twisted surfaces. In some of these, infinity lives side by side with closure. Paths repeat, patterns echo. The universe might tile itself endlessly like a cosmic mosaic, repeating structures far beyond our visible domain. And, perhaps the most humbling part is that all these models are consistent with what we see. Our observable universe is simply too small to distinguish between them. Imagine trying to determine the shape of an entire planet by examining a single grain of sand on its surface. We can infer, we can guess, we can model, but certainty eludes us. The question of infinity is not just a mathematical curiosity, it also shapes our understanding of existence. If the universe is infinite, then somewhere, in some unimaginably distant place, matter might arrange itself in patterns so similar to ours that duplicate versions of galaxies, or even of us, could exist. Not as mystical reflections, but as natural consequences of infinite combinations. If the universe is finite but unbounded, then everything loops. The cosmos would be like a grand, closed world, complete in itself, with its shape determined by the deepest laws of physics. And if neither of those is true, if the universe is finite and does have some kind of boundary, but one embedded in higher dimensional space, then perhaps our notions of edges, centers, and infinity must expand, growing beyond the limits of our familiar world. But no matter which possibility turns out to be correct, one thing remains constant. The observable universe is not the full universe. It is only the region that light has revealed to us. And beyond that luminous sphere could lie a cosmos that is vastly larger, perhaps infinitely larger than anything we have seen or imagined. And there is something quietly moving in this thought, because it suggests that our place in the universe is not insignificant or central, but simply part of a structure so vast that human intuition becomes too small to contain it. The night sky becomes not a ceiling but a suggestion, a faint whisper of something much larger. Cosmologists often turn to the mathematics of curvature to explore infinity. Space could have positive curvature, like a sphere, meaning it closes in on itself. It could have negative curvature, like a saddle, meaning it expands outward without ever looping. Or it could be perfectly flat, meaning the geometry is Euclidean on the largest scales. These shapes determine whether the universe is finite, infinite, or something in between. And measurements so far suggest near perfect flatness, which leans toward infinity but does not prove it. If the universe has curvature, it must be extremely subtle. But subtle curvature could still create a finite cosmos on scales far larger than we can observe. This leads to an almost philosophical question. Does it matter whether the universe is infinite if we can never reach even a fraction of it? In both cases, finite or infinite, our observable bubble is tiny, a drop in an ocean, a page in a book with countless chapters beyond our sight. Yet the question of infinity invites deeper contemplation. Infinity challenges our assumptions, reshapes our intuition, and humbles our perspective. It invites us to imagine a cosmos where the familiar rules of boundaries no longer apply, where space has no ending, no outer shell, no final darkness, or where space circles back, asking us to rethink what distance means. And here is where the cosmic microwave background returns to the conversation. That first light allows us to measure curvature. Those ancient temperature ripples, carved into the radiation like tiny brushstrokes on the sky, help us estimate the shape of space. And as we refine our measurements, we come closer to understanding whether the universe is truly infinite. But, each refinement seems to whisper the same quiet message. The universe is extremely flat, at least across the part we can observe. And a flat universe, if extended fully, would have no boundary, no edge, no endpoint, just endless space stretching outward into depths where galaxies drift like particles suspended in a cosmic sea. Yet this is where caution returns. Flatness does not guarantee infinity. We could live inside a finite universe whose curvature is so subtle, so gentle, that only a much larger observable region, perhaps hundreds of billions of light years across, could reveal it. Our instruments, in the era around 2025, cannot probe nearly that scale. It is like trying to feel the curvature of the Earth by examining a single room. The room feels flat, the Earth feels flat, but the planet curves just the same. And this brings us to the last and perhaps most intriguing idea. What if the universe is infinite, not just in space, but in possibility? What if the fabric of reality is shaped so that new regions of space continually emerge with the passage of time? What if cosmic inflation, the early burst of expansion, never truly ended in some distant regions, spawning endless pockets of space, each with its own properties? In that picture, our observable universe would be merely one bubble in a vast cosmic foam. But beyond each bubble lies more, not accessible, not knowable, but existing nonetheless. These ideas are speculative, yes, but they arise naturally from modern physics. They are not fantasies. They are extensions of equations and observations. But because they lie beyond observation, they remain possibilities rather than certainties. And so, as we stand at this strange crossroads, we find ourselves surrounded by the soft glow of uncertainty. The universe might be infinite. It might be finite but unbounded. It might belong to a hierarchy of structures beyond our observable domain. And through it all, our place remains small, humble, and profoundly beautiful. Perhaps the most meaningful truth here is that the question of infinity cannot be answered with light alone. It requires new tools, new ideas, new ways of thinking. But for now, our best guide remains the geometry traced into the cosmic microwave background, the faint ripples of early matter, and the delicate structure of galaxies across space. And well, once we begin to wonder about the scale of the universe itself, it becomes almost irresistible to take the next step. If space may be infinite, could there be more than the 3 dimensions we know? Could the universe be vast not just in extent, but in depth? Could there be hidden layers of reality, additional dimensions curled or stretched beyond our perception? Perhaps to follow that thread, we must drift gently into the next chapter and explore the tantalizing possibility that the cosmos may have more dimensions than the ones we see, and that the true shape of the universe may be far stranger than our senses can tell. Well, you see, once we begin to wonder whether the universe is infinite or simply vast beyond measure, a new and even stranger thought drifts quietly into the conversation, almost like a shadow slipping across the edge of our imagination. If space could be infinite in extent, then could it also be deeper than it appears? Could there be more layers to reality than the familiar 3 dimensions we move through every day? And perhaps this is where the universe invites us into one of its most enigmatic possibilities. The idea that the cosmos might possess hidden dimensions, unseen yet profoundly influential, woven into its very structure like threads beneath a tapestry. Our senses work in only 3 spatial dimensions: forward and backward, left and right, up and down. That feels complete because it fits our experience. But physics, especially the physics that tries to reconcile gravity with quantum mechanics, whispers that this apparent completeness may be an illusion. Many theories suggest that the universe could have additional dimensions curled so tightly or spread so subtly that we simply do not perceive them. They might not be places we can step into, but they could shape the behavior of particles, the distribution of forces, the birth of the universe itself. And well, this idea doesn't arise from fantasy, but from attempts to solve real problems in cosmology and quantum physics. Gravity, for example, behaves strangely compared to the other fundamental forces. It is weaker by far, almost suspiciously so. One proposal, elegant in its strangeness, is that gravity's apparent weakness arises because it spreads into extra dimensions, while the other forces remain confined to the familiar three. If that is true, then we live on something like a cosmic sheet, a brain, floating inside a higher dimensional space. And this is where things become beautifully surreal. In these models, our universe could be just one brain among many, each a kind of cosmic island drifting through a higher dimensional sea. These brains might collide, interact, or remain forever separate. If such a collision occurred in the past, some physicists speculate it could even resemble the Big Bang, a burst of energy created not from a singular point, but from the impact between higher dimensional surfaces. These ideas, though highly speculative, offer a tantalizing glimpse into possibilities far beyond ordinary experience. But perhaps the most delicate idea here is that the edge of the universe, the limit of what we can observe or measure, might be nothing more than the boundary where our three-dimensional brain intersects with these hidden dimensions. Not an edge in the traditional sense, but a limit in how far our space extends within a larger structure. Imagine a sheet of paper floating inside a room. The sheet has its own edges, its own boundaries, but those edges are not the edges of the room itself. They are simply the limits of the sheet. In this analogy, our universe could be the sheet, and the unseen room the higher dimensional reality. And when we consider this possibility, something curious emerges. If there are extra dimensions, then the observable universe might not be the entire stage. It might be the illuminated portion of something grander, a projection of a deeper, multidimensional architecture. The riddle, of course, is that we cannot step into those higher dimensions to inspect them. They must reveal themselves indirectly, through subtle imprints on the sky, distortions in gravity, or slight anomalies in particle behavior. But as of the era around 2025, no direct evidence of extra dimensions has appeared. The theories remain mathematically compelling, but experimentally elusive. The universe, in its quiet way, refuses to let us peek behind the curtain, and perhaps that is not surprising. If extra dimensions exist, they might be curled up at sizes far smaller than atoms, or stretched in ways that reveal themselves only through energy scales far beyond our current reach. Like a whisper drowned by cosmic noise, their presence may be hidden not by absence, but by scale. Still, the idea persists because it solves puzzles that otherwise remain stubbornly unsolved. Why is gravity so weak? Why does the universe expand the way it does? Why do particles behave the way they do? Some models even suggest that dark matter, the mysterious invisible substance shaping galaxies, might be matter from another brain, interacting with us only through gravity. In that picture, the cosmos becomes not a lonely void, but a layered structure of realities, each one drifting just beyond our perception. And, well, perhaps the most haunting part of these ideas is that the so-called edge of the universe might not be a border at all, but simply a place where our brain does not extend. The universe may appear finite in one dimension, yet infinite in another. We might be seeing only a cross-section of a deeper shape, like a thin slice through a much larger object. What we call the cosmic horizon might not be the edge of everything, but merely the place where our three-dimensional world fades into dimensional spaces we cannot enter. There is also the idea that the early universe underwent a period of rapid inflation, an expansion so extreme that quantum fluctuations were stretched across enormous volumes of space. Some inflationary models naturally produce extra dimensions as a byproduct. Others propose that inflation occurs on a brain embedded within a higher dimensional bulk. These higher dimensional theories, collectively called brain cosmologies, invite us to imagine that what we perceive as the whole universe is actually just one facet of a much larger structure. And, If that larger structure exists, then what seems like the edge of the universe, the farthest thing we can possibly observe, may be nothing more than the edge of our local patch of space-time. Beyond that, the higher dimensional bulk might continue endlessly, or it might contain other brains, other universes, each with its own physics and its own history. The cosmos would be a kind of grand archipelago, with each brain a cosmic island separated by higher dimensional waters. But here we must move gently, because evidence for such realms is sparse. We rely on mathematics, on patterns in the cosmic microwave background, on subtle predictions about particle interactions. And yet, even without direct proof, the concept remains compelling, because it provides a language for describing phenomena we do not fully understand. It gives us new metaphors, new tools, new frameworks. And the idea that the edge could be a dimensional intersection is particularly beautiful. In this picture, our universe is not limited by emptiness but by geometry. The limit is not a wall but a fold, a curvature, a boundary between dimensions. There might be no outside in the traditional sense, just directions we cannot move in. Much like a two-dimensional being cannot step upward or downward, bound forever to its flat surface. Perhaps the most profound implication is this: if extra dimensions exist, then the universe we see is not the ultimate version of reality. It is merely the one our senses can access. The true cosmos may be richer, deeper, more layered, with structures and landscapes far beyond our imagination. The edge becomes a doorway we cannot pass through, not because nothing lies beyond, but because our nature confines us. Yet, even as we drift through these possibilities, we remain anchored by one crucial truth. No matter how many dimensions the universe may possess, everything we can observe is shaped by the three we inhabit: our vision, our instruments, our telescopes, all tuned to the fabric of our own brain. The horizon remains the horizon. The observable universe remains the observable universe. The extra dimensions, if they exist, remain shadows dancing at the cusp of theory. Still, this entire discussion, strange and abstract as it may seem, prepares us for a deeper question. If space might curve, fold, wrap, or extend into dimensions beyond our perception, then what happens if you travel forever in a straight line? Can you ever reach an edge? Or would space-time, whether curved or flat, guide you back upon yourself, turning the universe into a loop without borders? Well, perhaps to explore that possibility, we must journey into the next chapter, where the idea of motion becomes our guide, and where the question of traveling endlessly through the cosmos reveals something profound about the true nature of space itself. Well, you see, after wandering through the possibility of hidden dimensions and drifting past the idea that our universe might be just one sheet in a deeper, higher dimensional expanse, a very human question quietly returns to us. It sits there, simple and childlike, almost innocent in its curiosity. If the universe has no center, if it might be infinite or curved or folded in ways we cannot see, then what happens if you just keep going? If you pick a direction, any direction at all, and travel in a perfectly straight line forever, would you eventually reach a cosmic edge, or would the journey continue without end, a path stretching into eternity? And perhaps this is where our intuition pushes against the deeper shape of reality, because in everyday life, going straight eventually brings you to something. You meet a wall, a cliff, a fence, a horizon. But the universe, does not mimic Earth. It does not promise an ending. It offers something stranger, quieter, more philosophical. The possibility that motion itself reveals the nature of space. If space is infinite and flat, for instance, then the answer is simple. You would travel forever. No matter how far you go, there would always be more. More galaxies, though increasingly carried away by cosmic expansion. More voids, though darkening into silence. More space-time stretching ahead of you with no finish line, no cosmic border waiting to greet you. In such a universe, your journey would become an endless dialogue with the expanding cosmos. Every step forward adds distance, but the destination remains untouched, unreachable by definition. And well, that is just the beginning. If the universe is curved, if space wraps around itself the way the surface of a sphere does, then the answer becomes even stranger. In that scenario, traveling straight forever might one day bring you back to where you started, not because you turned or changed direction, but because the geometry of space guided you along a loop. Just as an explorer on Earth can walk in a straight line and eventually return to their starting point, a traveler in a curved universe might one day look ahead and see their home galaxy shining before them, not as a metaphor, but as a literal consequence of cosmic curvature. But the curve of the universe, if it exists, is so gentle that within the observable sphere we cannot detect it. No telescope in the era around 2025 has found evidence of spatial looping, but neither has any instrument ruled it out. The cosmos keeps that secret folded quietly beyond our reach, hinting, but not confirming. So perhaps the universe curves in on itself at scales so colossal that it simply dwarfs our ability to measure it. And yet, even if space were curved, expansion complicates everything. You see, the universe is not a static arena. It grows. It stretches. It moves beneath you as you travel. A path that might once have looped back on itself could be pulled open by expansion faster than you can traverse it. You might set off hoping to return home in a grand cosmic circle, only to find the circle widening endlessly beneath your feet, expanding so rapidly that the loop becomes unreachable, your destination drifting away faster than you can chase it. In that case, traveling straight forever becomes a journey not through fixed geography, but through changing space-time. The universe itself becomes your moving landscape, and perhaps the most surprising truth here is that even if you traveled at near the speed of light, using technologies far beyond anything humanity currently possesses, you would never reach the edge of anything. Not because the universe is cruel or withholding, but because expansion ensures that the horizon always recedes. The very fabric of space-time stretches faster than your ship can fly. No matter how far you go, new space emerges ahead of you. It creates the feeling of a path without end, not because space is necessarily infinite, but because the act of traveling reveals that the universe has no fixed boundary to meet. If a finish line exists, it expands with you. The goalposts slide away. The universe denies the comfort of completion. This is why cosmologists often say that in most models, there is no final edge, not even hypothetically, not even in principle. You could journey for aeons and never find a border carved into the cosmic landscape. And if you attempted to chase galaxies at the edge of visibility, expansion would always stay ahead of you. They are not fleeing into empty space. The space between you and them is being created. And well, this is where the concept of geodesics, the straightest possible paths in curved space-time, becomes important. In flat space, a straight line is simple. In curved space, a straight line becomes something like a great circle on a sphere. And in a universe shaped by relativity, the straightest path is always determined by gravity, by curvature, by expansion. So when we say travel straight forever, we are not describing a simple line. We are describing a path carved by the geometry of the cosmos itself. And that geometry might send you looping, or drifting, or spiraling subtly through space-time. Another fascinating implication arises when we consider that your journey would also be shaped by cosmic horizons, those invisible boundaries created by expansion. Even if you travel forever, you cannot reach regions whose light will never reach you. They remain permanently inaccessible, not because they are distant, but because expansion stretches the distance faster than any traveler can compensate. In that sense, the universe is filled with places that are present but unreachable. You may move toward them, but the space between you and them grows faster than your motion closes it. It creates a strange dynamic. The more you chase the edge, the more it retreats. The universe is not a map. It is a process. And perhaps the deepest revelation here is that the idea of reaching the end only makes sense if the universe is static. But the universe we inhabit is alive with expansion, with curvature, with changing geometry. Motion through such a universe is not like motion on Earth. It is not a simple journey from here to there. It is a journey through evolving space-time. Even the notion of returning to your starting point must be considered carefully. If the universe curves, it might allow such a closed path. But expansion might prevent you from ever completing it. Or the loop might be so vast that even traveling at light speed would not bring you back before the stars have burned out, before galaxies have drifted apart, before space-time itself has transformed into a colder, darker future. And still, the beauty of this possibility remains. The idea that space could carry you full circle, not because you turned, but because space itself is shaped like a loop. Well, that is one of the loveliest ideas in cosmology. It suggests a universe with no edges, no walls, no singular boundaries. A universe where the infinite journey is not a punishment, but a property of the shape of existence. And you know, even if the universe is infinite and flat, the absence of an edge becomes its own kind of revelation. There is no wall to reach, no border to cross. The journey becomes a meditation on endlessness. You could travel forever, yet never exhaust the cosmos. You would always be in the middle of everything, regardless of direction or distance. This ties beautifully back into a deeper idea, that the universe is not built to be completed. It is built to be experienced, to be explored not in the expectation of reaching an end, but in the quiet acknowledgement that exploration itself is the reward. And perhaps this brings us gently to the philosophical heart of the question. If the universe has no reachable edge, then what does it mean to speak of limits? What are the boundaries that matter? If not spatial edges, then perhaps temporal ones. Because even if you travel infinitely far in space, you cannot travel infinitely far in time. Time has a beginning, at least for the part of the universe we can observe. There is a temporal edge, a boundary drawn not by distance but by history. And just as importantly, there may be limits to how far backward into time we can ever see. A cosmic wall not of space, but of time itself. So, perhaps to pursue this mystery further, we must shift our gaze from the distances we can travel to the ages we can explore. If space may have no edge, then maybe time does. And the story of the universe before the first light, before the cosmic microwave background, before even the earliest seconds, that story may be sealed behind a wall far more mysterious than any boundary of space. Let us drift there, then, into the next chapter, where we ask not how far we can go, but how far back we can see, and whether time itself has a beginning beyond which no light, no theory, and no imagination can reach. Well, you see, once we've traveled as far as motion can take us, forward in a straight line, across the stretching fabric of space, through loops that may or may not close, through horizons that recede faster than we can chase, there remains one last boundary we cannot ignore, a boundary not drawn in space but etched into the very flow of time. And, perhaps this is where the idea of an edge becomes something far more intimate, almost philosophical. Because even if space has no end, even if the universe folds back or stretches outward or hides within extra dimensions, time itself may have a beginning we cannot look beyond. A true horizon. A wall of history. You know, everything we've explored so far has been outward, toward distant galaxies, toward disappearing horizons, toward unseen realms beyond the observable universe. But now, the journey turns inward, backward, into the origin of everything we can see, everything we can measure, everything that has ever unfolded. And that backward journey has a limit, a place where time itself becomes opaque, a moment before which our tools, our theories, our equations can only gesture, like hands reaching through darkness. Scientists call this earliest moment the boundary of the observable past, the beginning of time as we understand it. And well, the truth is that we cannot see all the way back to the Big Bang itself, not even close. The cosmic microwave background, that soft whisper from the early universe, is as far back as photons can travel. Before that, the cosmos was too dense, too hot, too chaotic for light to move freely. Photons were scattered, trapped, swallowed, and re-emitted in a storm of plasma. The universe was opaque, a glowing fog with no transparency, no windows, no view. This fog acts like a temporal wall, a curtain drawn over the very first moments of existence, not because something is hiding there, but because the physics of that era prevents any light from carrying its story to us, just as the event horizon of a black hole marks the limit of what we can observe in space. This early opaque epoch marks the limit of what we can observe in time. And you see, this is the first great temporal edge, the earliest moment from which electromagnetic radiation can reach us, roughly 380,000 years after the Big Bang. Before that, the universe is closed to our sight, but this is only the beginning. If we keep moving backward in imagination, we find ourselves pressed against the next boundary. The universe grows hotter, denser, more extreme with each step. At a few minutes old, atomic nuclei are forged. Before that, temperatures soar so high that even protons and neutrons cannot remain stable. Roll back further, and quarks drift freely in a quantum storm. And further still, the universe becomes a true furnace of energy, its density so great that the known laws of physics begin to strain. And then comes the limit of our understanding, the Planck era, a moment so early, fractions of a second after the Big Bang, that our equations simply cannot describe it. Gravity, quantum mechanics, space-time itself all blur into something beyond our mathematical reach. It is not simply that we do not know what happened. It is that our current tools cannot even ask the question properly. In that era, space-time may have fluctuated wildly, expanding and contracting in quantum jolts. Or it may have been smooth, governed by a deeper law we have not yet discovered. Or perhaps time itself behaved differently, not yet settled into the continuous flow we experience today. Whatever occurred there, it lies behind a wall of theory, a wall not built from secrecy, but from the limitations of our models. And well, that brings us to one of the most astonishing facts about the universe. The Big Bang, as a concept, is not the beginning of everything. It is simply the earliest boundary our current physics can meaningfully describe. Whether time itself began at that moment, or whether something existed before, remains one of the deepest questions in cosmology. But we cannot look past it with light. We cannot reach past it with gravitational waves, at least not yet. We cannot step around it with mathematical certainty. This boundary, this temporal edge, is not a place we can travel to. It is a limit imposed by the structure of reality as we understand it, and it poses a question so profound that even now, in the era around 2025, physicists grapple with its meaning. Did time itself begin at the Big Bang? Or did the universe exist before, in some other state? Some theories suggest a beginning, an absolute starting point where space-time emerged from nothingness. Others propose a bounce, where a previous universe collapsed and rebounded, giving birth to ours. Yet others envision cycles, where universes arise, expand, cool, and fade, only to give rise to new ones. Still others imagine a quantum foam from which universes bubble into existence like sparks from a fire. But each of these stories hovers just beyond certainty, behind the temporal edge. And the most intriguing idea is that the edge of time may behave like the edge of space. Not a wall, not a barrier, not a moment of creation frozen in amber, but a boundary where our senses and instruments lose their ability to interpret what lies beyond. The Big Bang might be less like a point of origin and more like a horizon, a boundary between knowable and unknowable realms of cosmic history. Just as the observable universe has a spatial horizon created by expansion, our cosmos has a temporal horizon created by opacity, quantum limits, and the nature of time itself. Beyond that horizon, the universe may have existed in forms we cannot picture. Or perhaps time itself has no meaning there. This leads to another extraordinary idea. Time might not be a universal property. It might emerge from deeper laws. Before the universe cooled, before particles formed, before forces differentiated, perhaps time itself was not linear or directional. It could have been something else entirely, a dimension waiting to unfold. And, when people ask what happened before the Big Bang, they imagine something like a scene behind a curtain. But physics suggests that before may be a question without meaning. If time began at the Big Bang, then asking what came before is like asking what lies north of the North Pole, not because the answer is hidden, but because the question dissolves. Still, some models push past that linguistic boundary. They propose that space-time extends beyond the Big Bang, but is hidden from us by the laws of physics. They imagine universes branching, colliding, or eternally inflating. They imagine dimensions splitting and merging. They imagine cosmic epochs before ours, each with its own arrow of time. These ideas remain speculative, but they arise naturally from attempts to unify quantum physics with gravity. And as our understanding grows, as experiments reach deeper into the behavior of particles and the structure of space-time, we may inch closer to glimpsing what lies behind the temporal wall. And yet, even if we someday discover the mathematical truth of the universe's earliest moments, the observational truth, the ability to see or measure anything before the cosmic microwave background, may remain forever beyond reach. The universe denies us direct access to its beginning. But that denial is not a disappointment. It is a reminder that existence contains mystery at its core, a reminder that the cosmos is not a puzzle to be solved once, but an ever-deepening story. And that story continues to unfold in the structures we can observe. Galaxies forming, expanding, drifting into darkness, cosmic webs stretching across space-time, the whisper of gravitational waves trembling through the void. The boundary of time does not end our inquiry, it expands it. It invites us to ask, if time has a beginning we cannot see, does it also have an end? Will the universe continue forever, cooling slowly, dimming into silence? Or will it tear itself apart, or collapse, or transform into something new? These questions, too, bring us to the frontier of the unknown. They invite us to consider not only the universe's earliest moment, but its fate, its destiny. And well, perhaps to explore that deeper uncertainty, we must turn the page to the next layer of mystery. Because after tracing the boundaries of space and time, the next horizon is not physical at all. It is the horizon of our knowledge, the things science still cannot answer, the gaps, the silences, the shadows in our understanding. So let us drift there now, into the next chapter, where we confront not only what the universe reveals, but what it withholds. Well, you see, when we stand before the temporal wall of the universe, when we gaze into that earliest moment where our equations tremble and our understanding thins into haze, something remarkable happens. The questions do not end there. In fact, they multiply, they branch, they deepen. It is almost as though the boundary of time itself is inviting us to look not outward or backward anymore, but inward, into the structure of our own ignorance. And perhaps this is the most honest place to begin this chapter, with the realization that the universe is not obligated to be fully knowable. There are limits not only to what we can see, but also to what we can comprehend. You know, science has given us extraordinary tools, telescopes that can peer across billions of light years, instruments that can detect the faintest trembles in space-time, equations that describe the birth of particles and the fusion of stars. But even with all of that, vast regions of understanding remain in shadow. They are not blank spaces waiting to be filled. They are living frontiers, places where our current ideas collapse under their own weight, where the universe becomes too complex, too subtle, or too astonishing for the frameworks we have so far. And well, one of those frontiers is the nature of dark matter. We know it exists, not because we can see it, but because the galaxies themselves reveal its presence. Stars orbit faster than visible matter can explain. Clusters bend the path of light more strongly than their luminous components would allow. Something invisible contributes mass on scales we cannot ignore. But what that something is remains a mystery. It does not shine. It does not interact through electromagnetism. It drifts silently, shaping the cosmos without revealing its essence. Perhaps dark matter is made of particles beyond the standard model, particles that interact only through gravity. Or perhaps it is something else entirely, some form of structure woven into space-time, or a reflection of dimensions we cannot perceive. Even now, in the era around 2025, experiments beneath mountains and deep underground quietly wait, listening for the faintest tap from a dark matter particle. But the silence persists. And that silence forces us to ask whether our understanding of matter itself is incomplete, whether the universe contains ingredients we have not yet learned to name. Then there is dark energy, another mystery so profound that it reshapes the destiny of the cosmos. We know it accelerates the expansion of space. We know it dominates the universe's energy budget, but we do not know what it is. A property of space-time? A field filling the universe? A hint of physics beyond our grasp? The only certainty is that it drives galaxies apart with relentless pressure, and its presence ensures that many regions will slip beyond our horizon forever, untouchable even in principle. And well, when we speak of dark matter and dark energy, we are admitting something quietly humbling. Most of the universe is made of things we do not understand. The cosmos we see, the stars, the planets, the glowing nebulae, is only a fraction of the story. The rest lies in shadow, shaping reality while refusing to step into the light. But these are not the only unknowns. The universe also hides deep questions in its earliest moments. Inflation, the rapid expansion that is thought to have smoothed and stretched space-time in its infancy, is still only a hypothesis. It explains the observed uniformity of the cosmic microwave background. It predicts the distribution of galaxies. But its cause, its mechanism, and its deeper meaning remain elusive. Was inflation driven by a quantum field? By higher dimensional geometry? By the collision of brains? Or is it an approximation, a piece of a larger picture we have not yet grasped? And then comes the mystery of quantum gravity, the task of uniting the small-scale world of particles with the large-scale world of space-time. Our best theories break down when pushed into the earliest moments of the universe, when densities and energies become too extreme for general relativity to coexist with quantum mechanics. We know they must be reconciled, but we do not yet know how. Some theories suggest that space-time itself is granular, built from tiny discrete units. Others imagine smoothness, but embedded within higher dimensional manifolds. Still, others propose that space-time emerges from quantum entanglement, that geometry is not fundamental but born from information. Each idea offers pieces of a deeper truth, but none can yet claim certainty. And you see, these unknowns do not exist in isolation. They weave together, forming the fabric of our cosmic ignorance. They shape our models of the universe's evolution, its structure, its future. They remind us that the cosmos is larger not just in size, but in concept. Another puzzle lurks in the behavior of black holes. Their information paradox, their singularities, their holographic possibilities. Do black holes destroy information? Or do they preserve it on their surfaces, encoded in some deeper structure of space-time? The resolution to this paradox may reveal not only the nature of black holes, but the nature of the universe itself. And well, when we confront these mysteries, we begin to see that the universe is full of edges, not spatial edges, but conceptual ones, boundaries of knowledge, horizons of understanding. Every new discovery expands those edges, but every discovery also reveals deeper uncertainties beneath. Even the shape of the universe, flat or curved, infinite or finite, remains unsettled. Even the distribution of matter on the largest scales hints at patterns we do not fully understand. Even the arrow of time, the flow from past to future, raises questions. Why does time move forward? Why does entropy grow? Why does the universe evolve from simpler states toward complexity? These questions hover at the boundary between physics and philosophy, between measurement and meaning. And perhaps one of the most profound unknowns concerns consciousness itself, not as a biological function, but as a phenomenon embedded in a physical world. Why should atoms assembled in particular patterns produce awareness? Does consciousness simply arise from complexity, or is it tied to deeper structures in physics? Is the observer merely a product of the universe, or does the observer shape what can be observed? Cosmology cannot yet answer such questions. It may never fully answer them, but the very asking reveals how deeply intertwined we are with the cosmos we study. And another uncertainty lies in the fate of the universe. Will it expand forever, slow down, tear itself apart, or approach a quiet, eternal cooling? Dark energy holds the key, but its nature remains unknown. If it changes with time, the cosmos could face outcomes we cannot yet imagine. If it remains constant, the universe may drift into a distant future where galaxies fade beyond visibility, where stars burn out, where black holes evaporate, where space-time itself becomes cold and empty. And yet, that future is also unknown. The physics of the far future may reveal phenomena we have never encountered, perhaps new forms of energy, perhaps new emergent structures, perhaps endings that resemble beginnings. Each of these mysteries is an edge, not a dead end, but a frontier. A place where curiosity pushes against the unknown, where questions become more valuable than answers. And this is perhaps the most beautiful truth in all of science. The universe is not something to be mastered, but something to be explored. Its mysteries are invitations, not failures. Its silences are spaces where new ideas may someday bloom. But among all these unknowns, one stands out, a question that stretches beyond physics alone. If the universe might have no edge in space but a clear boundary in time, if it may be infinite yet inaccessible, flat yet curved beyond detection, then what does it mean for our place in it? Are we a cosmic accident? A momentary arrangement of atoms in an indifferent universe? Or are we part of something larger, something that unfolds purposefully or inevitably? And, well, perhaps to wrestle with that final question, we must turn not to data or equations, but to meaning, to stories, to the philosophical weight of being a conscious creature in a universe so vast, so ancient, and so mysterious. So let us drift now, gently, into the next chapter, where the scientific edges give way to human ones, and where the question is not what the universe is, but what it means for us to live inside it. Well, you see, once we've walked all the way to the edges of knowledge itself, past the boundaries of space, past the horizons of time, past the limits of light and observation, we find ourselves standing before a different kind of frontier, not a cosmic wall, not a veil of radiation, not a mathematical curvature, but something far more intimate, the edge created by our own minds. And perhaps this is where the universe becomes more than a physical place. It becomes a mirror. The idea of a boundary has always shaped human understanding. Children draw lines around the world to make sense of it. Explorers sailed toward literal horizons. Philosophers drew borders between the known and the unknown. But when we place this idea onto the universe, when we imagine a cosmic edge, it reveals as much about us as it does about the cosmos. We crave edges because edges suggest shape, meaning, structure. Yet the universe, patient and enigmatic, refuses to give us any such comfort. And well, this leads us into the philosophical view of the cosmic edge, not as a place, but as a metaphor for the limits of human perception. Every scientific boundary we've traced in the previous chapters is also a cognitive boundary, a place where our understanding fails not because the universe hides its secrets maliciously, but because our tools and senses were never designed to grasp the entire tapestry of reality at once. In that sense, the edge of the universe is just as much a frontier of the mind as it is a frontier of space-time. Perhaps the most profound realization is that we, as conscious beings, exist permanently at the border between what we know and what we long to understand. We are creatures standing in a dimly lit room, pressing our hands against a glass wall that looks out onto endless darkness, and only through curiosity, through the fragile, persistent light of inquiry, do we push that wall outward, bit by bit, expanding the region of the knowable. But that wall never disappears. Its presence is part of being human. And you see, when philosophers talk about limits, they aren't simply describing obstacles. They are describing the shape of awareness itself. The universe may have no physical edges, but we do. Our language, our perception, our logic, all are finite containers trying to hold something infinite in possibility. What we call the edge is really the place where understanding gives way to wonder. And perhaps wonder is not a weakness. Perhaps it is the very thing that keeps us moving forward in a universe that does not end. There is another layer to this philosophical view, the question of our place. If the universe is vast beyond measure, possibly infinite with no center and no privileged vantage point, then what does it mean to be here, on this small, pale world drifting in an ocean without shores? For some, that thought seems to shrink humanity, reducing us to specks. But for others, and I suppose I share this view, it expands us. It reveals that consciousness is not an accident. It is the universe becoming aware of itself through fragile beings bound to a moment in time. Our questions about the cosmic edge are not distant curiosities. They are expressions of something deeply human, the desire to find meaning in a place that offers neither instructions nor explanations. And well, if the universe has no edge, then perhaps meaning is not given at the boundary of existence. Meaning emerges from the journey itself, from the attempt to understand, from the way we choose to live and perceive and wonder inside this enormous, unfolding story. Another philosophical ripple moves through the conversation when we consider that every edge humanity has ever imagined eventually vanished as our knowledge grew. The edge of the earth dissolved with exploration. The edge of the solar system dissolved with telescopes. The edge of the galaxy dissolved with deeper surveys of the sky. The edge of the observable universe dissolved into a horizon defined not by walls, but by light and time. So perhaps the cosmic edge, this final frontier in our imagination, serves a different purpose. It humbles us. It reminds us that certainty is a luxury the universe does not provide. It teaches us that living with mystery is part of being alive. And you know, there's another thought here, quiet but important. Maybe the idea of an edge exists because the mind cannot easily picture infinity. Infinity is not a place. It is not a direction. It is not a number. It is a gesture towards something that cannot be held all at once. So we imagine walls, boundaries, rims, not because the universe requires them, but because our imaginations do. But when we release that need for a boundary, when we allow the universe to be as boundless as the evidence suggests, something beautiful happens. The cosmos becomes less like a container and more like a field of possibility. Every point becomes a center. Every moment becomes a beginning. And the edge becomes not a location, but a state of mind. From this perspective, the cosmic edge reveals a truth about human existence. We live in the middle of a question, not the answer. We exist not at the end of something or the beginning of something, but inside a curious and unfolding mystery. The more we learn, the larger that mystery becomes. Knowledge does not shrink the unknown, it expands it. And well, perhaps that is the true philosophical edge, the place where we confront the limits of our understanding and realize that the unknown is not our enemy. It is the very source of awe. Without it, the universe would feel flat, predictable, silent. Instead, it offers complexity, strangeness, and beauty, qualities that stir our minds and give shape to our longing to explore. Another insight emerges when we ask why humans even care about the edge of the universe. What are we really looking for when we ask where it ends? Are we searching for boundaries or for belonging? Are we trying to locate ourselves in something immeasurable? Or are we trying to justify our significance within a cosmos that appears indifferent? The edge, viewed philosophically, is really a frame for these deeper questions. It is a way of asking, what does it mean to be here? Why is there something rather than nothing? How do we find purpose in an existence without clear design? And perhaps the beauty of the edge is that it refuses to answer. It forces us to create meaning rather than discover it, to shape our own stories rather than wait for the cosmos to reveal a script. You know, thinkers throughout history have wrestled with this tension, the desire for certainty in a universe that offers ambiguity, the longing for structure in a universe that stretches beyond comprehension. But they also recognize that this tension is what makes consciousness meaningful. To exist is to dwell between the known and the unknown, to live in a perpetual state of becoming. And if the universe has no physical boundary, then our journey has no final destination. We are not heading toward an edge. We are moving within an evolving horizon of understanding. And that horizon expands with each question we dare to ask. This is why the cosmic edge becomes a metaphor for growth. It marks the outer limit of what we know today. But tomorrow it will move. It always moves. As long as there are minds to imagine, to wonder, to explore, the edge will never remain still. And well, perhaps the most poetic way to see it is this: the edge of the universe is not a distant place. It is wherever our understanding falters, wherever mystery begins. And every time we take a step into that mystery, through science, through philosophy, through imagination, the universe grows a little larger inside us. So maybe the real question is not where the edge is, but what kind of beings we become when we choose to walk toward it. And as we drift gently toward the close of this chapter, another question rises, soft and inevitable. If the universe refuses to give us a final boundary, then what lies beyond even the concept of an edge? What deeper mysteries remain? Mysteries that stretch past physics, past philosophy, into realms where understanding itself must be reinvented. Perhaps, to follow that thread, we should step quietly into the next chapter, where we reflect not on the boundaries of the universe, but on what those boundaries reveal about the nature of reality itself, and the future of our search for meaning within it. Well, you see, after wandering through all these layers, scientific, philosophical, personal, we begin to sense that the universe, in all its vastness, is offering us something more subtle than an answer. It is offering an invitation. Because once you realize that the cosmic edge is not a location, but a shifting frontier of understanding, a quiet and profound question begins to form beneath everything else. What lies beyond even that? Beyond the boundary, not of the universe, but of our ability to conceive what the universe might be. And perhaps this is where chapter 13 gently unfolds, not as a conclusion, but as a turning point, a widening of perspective, a reminder that even the idea of an edge of the universe sits within a larger mystery, the nature of reality itself. You know, every scientific horizon we've explored, observable limits, cosmic expansion, early opacity, quantum boundaries, points towards something bigger, something that cannot be captured by equations alone. We begin to sense that the universe is not just a physical object to be measured, but a phenomenon to be interpreted, a story that stretches beyond the tools we use to study it, a story that includes us, our questions, our limitations, and our longing for meaning. And well, when we sit with that realization, something remarkable happens. The cosmic edge becomes a doorway. It opens onto the question of what existence is made of, what laws shape it, what truths lie beneath even the deepest physics we have. At this point, science and philosophy don't separate. They intertwine. They fold into one another, like two currents in the same ocean. One of the facts that often surprises people is that the very concept of reality is not straightforward. Quantum mechanics shows us that particles behave in ways that defy intuition. Relativity shows that time and space flex under mass and motion. Cosmology suggests that the universe may be only one bubble among many, perhaps one version of reality among countless others. And then comes the strange, gently unsettling question: if reality can take so many shapes, what anchors it? What defines the deeper structure beneath all of this? And you see, this is where the edge becomes symbolic. It represents the limits of our models, our categories, our assumptions. It marks the place where we must admit that the universe might not conform to the framings our minds evolved to understand. Just as ancient maps once placed sea serpents at the edge of the known world, our modern maps place equations, variables, and speculative theories at the frontier of the unknown. But we must recognize that this boundary says as much about us as it does about the cosmos. Perhaps the most profound fact about the cosmic edge is that it reveals how human understanding works. We build meaning outward from what we can measure. We name things. We classify. We define. But the universe resists final definitions. The deeper we go, the more questions rise from the shadows. The more answers we uncover, the larger the unknown becomes, unfolding like a dark flower in the depths of space-time. And well, maybe the edge of the universe is not an end point, but an ever-receding horizon that teaches us humility. It reminds us that comprehension is not an end state. It is a journey. And we, for all our cleverness, are travelers, not owners, of cosmic truth. Another fact that belongs here is the idea that the universe might be part of a larger multiverse. Not in the science fiction sense of parallel worlds with versions of ourselves doing impossible things, but in the sense that the cosmos might be just one realization of physical law among many. Inflation theory naturally gives rise to this possibility. Quantum theory hints at multiple outcomes encoded in wave functions. Even the mathematics of string theory suggests vast landscapes of possible universes. But even if these multiverses exist, they lie permanently beyond observation, beyond measurement, beyond demonstration. They cannot be proven or disproven by data within our universe. And so they sit at the boundary, half scientific, half philosophical, reminding us that some aspects of reality may forever belong to speculation, not certainty. You know, as we reflect on all of this, it becomes clear that the edge of the universe is not merely a scientific puzzle. It is a human mirror. It shows us what meaning means in a cosmos that does not create meaning for us. It shows us the difference between explanation and understanding, between knowledge and wisdom. Because once you accept that the universe has no physical boundary, no outer wall, no cosmic rim, you begin to ask a deeper question. If the universe doesn't define our limits, then what does? And slowly, gently, you realize that the true boundaries are internal. They are shaped by curiosity, by fear, by imagination, by the capacity of the human mind to reach beyond itself. In this sense, the edge of the universe becomes a metaphor for every frontier we encounter in life. The edge of understanding, the edge of experience, the edge of identity. We are always standing at some boundary, always stepping into the unknown, always learning who we are in the vastness around us. And perhaps that is why the cosmos feels so strangely familiar. Because in the endless expanse of space, we see our own search for meaning reflected back at us. The universe stretches not only outward but inward, into our concepts, our questions, our sense of belonging. One of the most quietly beautiful facts is this: humans are the only species we know that can imagine the edge of the universe. The only species capable of contemplating infinity, grappling with time, wondering what lies beyond. That ability, to ask questions the universe does not force upon us, is itself a kind of miracle. It is as though consciousness is a bridge between the universe's silence and the universe's meaning. And well, this leads to another philosophical insight. Perhaps the cosmic edge teaches us that understanding is relational. The universe does not speak. It does not give explanations, but it responds to our curiosity in the language of evidence and discovery. It reveals what we seek piece by piece through the structure of space, the flow of time, the behavior of matter, and in return we must approach it with humility, because you see, the universe is not obligated to be simple, or comforting, or comprehensible. But we are obligated, if we want to understand, to remain open, to remain curious, to accept uncertainty as a companion rather than a threat. And then comes the final philosophical ripple. The cosmic edge reminds us that we live inside a question, not an answer. We exist in a state of perpetual inquiry, and this might be the most meaningful truth of all. The universe does not shape itself to suit us, yet we shape ourselves through the act of exploring it. The frontier of the unknown becomes a teacher. It teaches patience, humility, imagination. It teaches us that life has value precisely because it is brief and fragile in a universe that is huge and ancient. It teaches us that meaning is not discovered at the boundaries of the universe. It is created at the boundaries of the mind. And as we drift toward the end of this chapter, a new question emerges, one that seems to glow softly beneath everything else we have explored. If the universe has no edge, and if understanding has no final limit, then what lies beyond the horizon of what we can become? Perhaps to explore that final mystery, we must step gently into the next chapter, where the conversation shifts from the universe's boundaries to the unfolding future of our relationship with the cosmos itself. Well, you see, after wandering through all the questions that have shaped this long journey, the edges of space, the limits of time, the mysteries of dark matter, the silence beyond the observable horizon, and the fragile boundaries of our own understanding, we finally arrive at a place that feels less like an ending and more like a quiet breath. A moment of reflection, a recognition that the universe, vast and ancient as it is, has been guiding us not toward a final answer, but toward a deeper way of seeing. And perhaps that is what a conclusion really is in a story like this. Not a closing door, but a soft turning of the head, a shift in perspective, the sense that we have walked far enough to appreciate how much farther the path might go. You know, one of the most striking realizations we uncover along this journey is that the edge of the universe was never a place. It was never a wall or a border or a final shimmering line in the dark. It was always a question, one that revealed as much about our own minds as it did about the cosmos. When humans imagine an edge, what we're really imagining is the boundary of understanding, the limit of sight, the frontier where curiosity meets silence. And yet, every time we push against that frontier, the universe expands, not by changing its shape, but by changing ours. And well, when we look at how far we've come, from imagining a cosmic wall at the end of space to understanding horizons shaped by light and time, it becomes clear that the universe is not simply a physical structure. It is a teacher, a patient one, a quiet one that reveals itself slowly, in hints and echoes, as though encouraging us to become the kind of beings capable of listening. Perhaps the most profound truth we uncovered is that the Rhea of the universe is not something outside us. It is something within us. It is the limit of our perception, the limit of our theories, the limit of what we can measure with our tools in the early decades leading toward 2025. And yet, this limit is not fixed. It grows. It shifts. It recedes as we move toward it. Every question we ask pushes it a little farther into the dark, and each time it moves, we discover that the universe was always larger than we thought, not only in distance, but in meaning. And you see, perhaps that is the real significance of the cosmic edge, not as a place where the universe ends, but as a reminder that understanding has no final boundary. That curiosity is infinite, that our hunger for meaning is part of what binds us to the stars. When ancient humans looked at the night sky, they did not see galaxies or cosmic microwave backgrounds or red-shifted horizons. They saw mystery. Today, with telescopes and equations and deep sky surveys, we see mystery too, but in a different form, a more precise form, a form wrapped in data and theory, but still beating with the same human longing that guided those early stargazers. And perhaps what moves me most is the realization that the universe does not shrink when we understand more of it. It grows. It becomes more intricate, more subtle, more wondrous. Each answer becomes a doorway. Each discovery becomes a horizon, and each horizon reveals that the cosmos is not merely a cold expanse of matter, but a living archive of questions. You know, when we stand beneath the night sky, even now, on this small world orbiting an ordinary star, we are standing at the intersection of everything that has ever existed and everything that might yet be. The atoms in our bodies were forged in stars that lived and died billions of years ago. The photons touching our eyes tonight may have begun their journey before Earth existed. We are stitched from the universe's memory, carried forward by its expansion, and sustained by physical laws that trace their origins to moments we can barely imagine. And when we speak of the edge of the universe, perhaps we are really speaking of the edge of this connection, the boundary where our story touches the larger story of existence. And well, if the universe has taught us anything, it is that this boundary is permeable. It invites us to step through it, not physically, but intellectually, emotionally, spiritually, in a quiet, secular way. Each time we do, we find ourselves more deeply woven into the fabric of everything. There is also something profoundly human in the fact that we seek edges at all. We want to know where things end, because endings give us shape. They help us understand who we are. But the universe refuses endings. It offers continuations, expansions, transformations. It offers horizons instead of walls, ambiguity instead of closure, possibility instead of finality. And maybe that is not a limitation. Maybe it is a gift. Because if the universe had a final edge, if it truly ended somewhere, our curiosity might end with it. But because it doesn't, because it keeps stretching outward into mystery, so do we. We grow as it grows. We ask more. We imagine more. We feel more. The edge keeps us moving. And you know, as we reflect on all of this, a gentle shift occurs. The universe ceases to be something out there and becomes something we are part of, not separate from, not observers watching from the sidelines, but participants in a cosmic story unfolding across time and dimension. A story written in starlight and dark matter and quantum possibilities. A story whose ending is not yet written. And perhaps the most beautiful truth is that this story continues as long as we continue to ask. The edge of the universe remains open because we remain open. So, if we gather all the threads of this long journey, scientific, philosophical, emotional, they converge into a single realization. The Rhea of the universe is not a place we discover. It is a perspective we outgrow. The cosmos does not tell us where it ends. It tells us how far we have come. And well, once you see that, you begin to realize that there is no real ending to this exploration, only the continuation of a much larger question. And perhaps that is where this journey naturally leads us next, not toward a boundary, but toward a deeper mystery. What lies beyond even the idea of an edge? What lies in the territories of existence we have not yet learned how to describe? To follow that question, we must step softly into the next part of the story, into a place where the universe's unknowns intertwine with our own possibilities, and where the future of our understanding stretches out like a new horizon waiting to be named.